Assalamualaikum and a very good day. Today, our team from Group 5 like to discuss more about variation analysis for analysis. Let me introduce our team first. So my name is Muhammad Faiz bin Jasmine.
My name is Abdul Aziz bin Hamad Sifudin.
My name is Ahmad Sirazi bin Ahmad Fazil.
My name is Muhammad Ahmad Zafri bin Muhammad Dun.
And my name is Shafianani binti Shamsuddin. So I guess we can continue discussing on the first question. Take a look on the diagram. Check all the criteria that we need to check on in order to proper diagnose the machine. Okay, first of all, we need to check on the dominant direction. In my opinion, based on the diagram, you can see that the radial is greater than the axial. So Aziz, do you have anything to say about this?
I think I agree with you. Radial is greater than axial.
I agree
For
with that
me-
statement too.
We agree too.
Yes,
I
I
agree.
agree.
I think we can check
yeah.
idea that the condition of the radial greater than axial. So maybe we can assume that this is misalignment or others.
Yeah, that seems correct.
It also can be imbalanced because the radial is bigger than axial. Either imbalance, misalignment, or looseness. Since the radial is bigger than axial.
I think from the misalignment is from parallel, right? Maybe from the angular axial greater than radial. So maybe we can
I
assume
think
parallel.
we can neglect misalignment angular since axial is greater than radial. Other than that, maybe bend shaft and cord bearing because these three is axial is greater than radial.
Try check first the dominant direction of this step 1. Actually, we assume right, radial is
Yes.
greater than the axial.
Yes.
So maybe we can proceed with the step 2. Check the dominant frequency. So how about the others?
Sure, let's move on.
We can see that there is 1x, 2x, and 3x in the diagram. And based on the diagram itself also, we can see that 1x is greater than 2x or 3x.
Yeah, you are.
You are right.
You
Yeah.
can see 1x
So let's
greater than 2x.
I guess we can eliminate the imbalance because imbalance only will have one x dominant. So only left us with misalignment and looseness.
Yes.
Okay.
Misalignment.
Right.
So the dominant is 1x, 2x, and 3x. Actually, 1x greater than 2x. Try to check the radial phase different. So others can try.
So just now we are assuming that it may be the parallel misalignment. So how about we calculate the phase difference first? Maybe we can check in this diagram. It shows that the dominant is on the point 2 and 3. So we can for parallel misalignment we can check for the horizontal and vertical. So on 2 on 3 for vertical, the phase difference is 210 minus 50, which is 160 for the vertical.
Yeah,
I agree
I can-
with you. Because if we can see at unbalanced, to calculate the phase difference is at 0.1. So I think if we can see the question, the graph is dominant at 2 and 3. Beside vertical, horizontal, we can calculate by 2h minus 3h, which is 190 minus 35. The answer is 155. So I think it's still in phase.
I think so. I agree with Shirazi and Aziz because it's still in range around 180 plus minus with 30. So we check first the radial phase difference for this coupling. So actually, it's correct that the range for the vertical and horizontal is still in phase 180 plus minus 30. So maybe we can try to check the axial phase difference.
So for the axial
Ya,
phase,
Amar.
to find this particular category, we can calculate 2A is 45 and 3A is 205. So by calculating the difference between these two values, we're going to get a value of 160, which is still in the radial phase range. How about the others? Do you agree with this?
Yes, I agree.
Yeah,
I think we can assume right about this is parallel misalignment, right? Because it's still the
Yeah.
axial phase different is still a range 180 plus minus 30, right?
Yep.
Yes.
Yes.
Yes, it may be, can be parallel misalignment.
So it's correct that I must say that it's still a range for the Asia. So we try to check the criteria next for the parallel misalignment.
Yeah, I guess we have fulfilled all the criteria for the parallel misalignment for this diagram.
So the answer is parallel misalignment. So all of you agree with this?
Yes, I agree.
Yep, I
Yeah,
think so
okay.
too.
So we look on this question. So we need to check first all the point that given. So we use a same method from the question one before. So let's first we check the dominant direction.
In my opinion, based on the question, I can see that axial is greater than radial.
I agree with you. It is the axial is greater than the radial.
How about the others?
I agree, but can you
Yeah.
explain a little bit more to why it is dominant? Because on the first point, we can see that there are still some maximum vibrations on the first point too. So can you please explain it further?
I think because at for radial, we can see that the graph is higher at point number 1. But we can see at the Asia, we can see that at point 2 and 3, they have two places that have higher vibration occur. That's why I assume that Asia is greater than radial.
Thank you for the explanation.
We can
I
try to
understand.
check the dominant direction for the question 2. So yeah, the Asia is greater than radial. So maybe we can try to assume for this question is more about what? So I think maybe we can try to assume that angular misalignment, or we can try to assume that maybe top bearing. How about the others?
I think it's
It can be
maybe
bench.
yes, it can be bench shaft too.
I think both of those possibilities are true.
So maybe we can try to proceed with step 2, check the dominant frequency. So from me, the dominant is from number 1x, 2x, and 3x. So we can see that from point 2 and point 3, 1x is greater than 2x. Am I right?
Yep, you are.
Yes,
Yep.
you can see clearly that 1x is dominant than 2x.
How about
I think
the...
you can check them.
We can try check.
Yeah, we can check.
We can try to assume that it's maybe angular misalignment, right?
Yeah, it
Seem
can
more
be.
like
Dominant
it.
frequency.
Yes, maybe it can be.
So we can try to
Because,
neglect
I mean-
the others, top bearing and bench shaft.
But we have to check the others to make sure that our diagnosis for this diagram is correct.
So we try to go with other step. So we can try to check the radial phase different across the coupling.
Step 3 for question 2 is still pretty much the same with step 3 with question 1, where we can calculate the radial phase difference between 2 and 3V, which will get the value of 7. How about the others? Do you think this is correct?
Yes.
It is 7.
And maybe we can check also the other horizontal for at point 2 and point 3. The phase difference for the 2H and 3H. 2H is 62 and 3H is 59. So the phase difference is 3. And if I'm not mistaken, it is still in phase, which is the criteria is plus minus 30.
So
Yeah,
we
0
am I right?
minus 30.
can try to assume that this is from angular misalignment, right? Because it's in
Yeah.
point 3.
Yep, it's looking more like it.
Right, for the angular misalignment, we need to get the range 0 plus minus 30, right? So
Yep.
actually we check from the radial phase different from the point 2 and point 3 we get 7 and 3. So maybe we can assume this is angular misalignment, or we need to proceed to step 4.
I think we need to proceed to
I think we can
step
just
4.
proceed.
So we try to check axial phase different across the coupling.
Well, for the actual differences at point 2 and point 3, which point two is 23 and point three is 218. We can see that if we see the differences, it will be around 195 degrees. So it is between the range of 180 with tolerance of 30 degrees.
I think it's
Yeah,
still
it's
in
still in
phase for the point 3
for
and
the
point 2.
angular misalignment.
Maybe we can try to check with the criteria for the angular misalignment. So maybe we can get all the possibility that we discussed before. Maybe we can conclude that this is an angular misalignment or not. First, we can check that the dominant direction is TS, XJ is greater than radial. And then for the dominant, 1x greater than 2x. And then in step 3, we check the radial phase different across the coupling. Yes, it's still in range, in phase. And then for the check for the axial phase, it's still in phase. So maybe we can conclude for the question 2 is angular misalignment, right?
I agree with that statement.
Yes.
So we can check the answer. So this is angular misalignment. Can we try to proceed with question 3?
Sure.
Yes, sure.
Alright.
Let's go.
Let's we proceed with question 3. So maybe we can try the same method that we get the answer for question 1 and question 2. So we try to check the dominant direction first. From my overview, I can see that the axial and the radial is same, right?
Yeah, it is
Yes,
somewhat
I agree.
relatively the same.
Yeah,
Yeah.
the direction for the dominant direction for is quite similar for the axial and the radial, right?
So maybe we can try to proceed with the answer. The axial is same with the radial. So how about the criteria that we can assume first?
Overhang imbalance.
Yeah,
Possible.
Yes.
I don't think
Maybe.
there's any other criteria that fit this particular situation.
Agree. But I think we have to check the others as well just to make sure that we are doing it we are on the right path.
So-
for dominant,
I think that 1x is dominant.
it is obvious.
So how about the others?
I agree.
Next, check the radial phase different at the same point.
Maybe I will give a try on this radial phase. As we can see, the radial phase is quite high at the point 3 and 4, so we gotta check on the point 3 and 4. So point 3, 3V and 3H, the phase difference is 3V is 108 and 3H is 13. So the phase difference will be 95. And at point 4, for 4V and 4H, 4V is 251 while 4H is 158. So the phase difference will be 93. We can assume it is in phase because the phase is 90 degree plus minus 30 degrees tolerance.
I agree with Aziz because it's still in the tolerance value with 0.3 and 0.4. So maybe we can try to assume right, it's still in phase.
Yes.
Yeah.
It is still in phase.
So try to see the unbalance criteria first. So we can try to conclude that this is unbalance, right?
Yep.
Yep,
Yes.
it is. It is.
So maybe we can try to check with the specific criteria for the overhang unbalance. Maybe we can get obviously is overhang or not.
As we can see at the question, we need to use 3A minus 4A, which is 3A is 119 minus by 4A, which is 98. The phase for Asia is 21. I think it's still in phase. Range is 0 plus minus 30.
I guess based on the four criteria that we have calculated or discussed before, it is obviously overhang unbalance.
So we see for the specific criteria, maybe we can see at axial and vertical right, and then we try to calculate the answer. Maybe we can assume the same opinion about this. Maybe this question 3 is overhang imbalance. So all of
Yes.
you agree with this?
I agree.
I agree.
So we assume this is overhang imbalance. Alright, that's all from question 3. So let's proceed with question 4. So maybe we can try to do with same method with question 1 and question 2 and question 3. So let's check first the dominant direction.
As we can see, maybe the diagram, I think it is obvious that the radial is greater than axial for point 1 and which is the point 1 and point 2. Point 1 is the highest, so it is radial is greater than axial.
I think
I
with
agree.
Aziz. How about the others?
So you stated that radial is greater than axial, correct?
Yes.
Is this because of the dominant, not dominant, but the maximum vibration at point 1 and point 2?
No, the highest is on the 1x at point 1. So for the overall is at the radial is the highest as we can see at point 1.
I see, okay.
So we can conclude that the radial is greater than axial. So maybe we can try to check first the dominant direction. So radial is greater than axial. So maybe we can try to assume what the criteria is suitable with the radial is greater than axial.
I guess we can eliminate band shaft, chord bearing, and then overhang unbalance, because for band shaft and chord bearing, the dominant direction is axial is bigger than the radial, which for ours right now is radial is greater than the axial. I think the only left is imbalance, misalignment, and then looseness. Those
I
are the only.
think angular misalignment also can neglect,
Yeah.
because angular misalignment is axial is greater than radial.
So it's on the 3/4
Which option that we can try? So maybe we can check with the dominant frequency. Actually, we can see right the 1x is more dominant rather than the others.
high vibration on the 1x.
Yes.
Yeah.
Yep.
Alright, we can try to neglect for the others.
Misalignment.
Misalignment, parallel misalignment.
I think the only cases we have
Balance
unbalance and
and looseness.
type A. Let's continue for the next step.
Okay, next step, we try to check the radial phase different at the same point.
Yeah, maybe Nani wanna give a try.
So we can check the radial phase for the 1V, 1H, 2V, 2H, 3V, 3H, and then for 4V, 4H. So 1V, 1H is 115 minus 8 will be around 107. And 2V, 2H will be 285 minus 190, which equals to 95. Whereas for 3V, 3H will be 59 minus 18, that will be 41. And lastly for 4V to 4H, this difference will be 91 minus 87, which equals to 4. Can we check whether the right calculation?
Alright.
Yeah. So I think based on this radial phase, we can tell that there is a differences for point 1 and 2 and point 3 and 4. And based on the lecture notes, we can see when there is a phase difference for the motor and for the pump, we kind of can assume that the fault will be under looseness type A structural looseness. Do you agree?
I understand and I agree with your statement.
I have a question. Why you say that it may be a looseness? So can you explain further about the different phase on the motor, or maybe someone can explain?
Maybe from me, the highest from 1x in the horizontal and the vertical, we can see is more high from the axial. So we at the point 1 and point 2, actually we can see that point 1 and point 2 is in phase, and point 3 and point 4 is out of the phase. So we can assume the answer will be the looseness type A for this answer.
Maybe you can someone can explain further about the criteria on the structural looseness.
I mean, as I mentioned before, that there is a differences in phase difference for the motor and the pump. Because if we check on the criteria for the imbalance, we can see that for the 1V, 1H, 2V, 3H, 3V, 3H, and 4V, 4H, the phase differences will be somewhere around in the range of 90 plus minus 50. But as you can see from the calculation that we calculated before, the answer for each points are not within the range. So we cannot assume that it is under imbalance. So the only choices that we have for this situation is looseness for type A, because it is mentioned in lecture note that if there's a phase differences on the motor and on the pump, it will be looseness type A. And not to mention, 1x is dominant in this situation for the horizontal and vertical. So somehow we can conclude that it is looseness. Is it clear for you?
It is clear for me. For my understanding, it is about the location itself of the motor. So the looseness is on the motor and the foundation. So that's why you choose it is under the looseness structure.
Yeah.
Structure.
So all of us agree, right? The answer will be looseness type A.
Yes.
Yes.
So we agree.
So for the question 4, we try to conclude that this is a looseness type A, structural looseness and a weakness. So for the conclusion, question 1, we can conclude that this is a parallel misalignment, and question 2 is angular misalignment, and question 3 overhang imbalance. For question 4 is looseness type A, structural looseness, weakness. So all of us agree.
Yes, I
Yep.
agree.
We are.
I agree.
So thank you for participate for this discussion. So let's end and this discussion with thanks. Thank you everyone.
Thank
Thank
you,
you.
everyone.
Thank you.